I did problem F10-8, and for this one, I drew the picture here with the dimensions, and we're determining the moment of inertia of the cross-sectional area of the T-beam with respect to the x-axis passing through the centroid of the cross-section. So first I just drew my table and labeled this one as shape 1, this one is shape 2. And I went ahead and found the area first, and they both happen to be the same. So it's just length times width. So 150 times 30 for shape 1, and 30 times 150 for shape 2. So they both end up being 4,500. And then I found the distance from Y, just in the Y direction to the centroid. So for object 1, it is the height of this shape divided by 2. And then for object 2, or shape 2, it is this height. So 30 plus 150, which is the height of the shape 2, divided by 2 will get you this. So I did 30 plus 150 divided by 2, which gives me 105. Then I found the IXX for both shapes. So if you remember that formula, it is base times height cubed divided by 12. So for this one, for shape 1, I did 150 times 30 cubed divided by 12. And for this one, for shape 2, I did 30 times 150 cubed divided by 12, which gives you these values here. We're going to use that later. Then I found the centroid of the shape. So if you remember to find that, it is this formula right here. So yi, the sum of yi times ai divided by the sum of ai. So I just plugged in those values from our table right here, which gives us 60 meters. So that is where our centroid in the y direction gives us the centroid of the shape at 60 meters. And so to find d, that's the distance from this 60 meters to each centroid shape. And so if you calculate it for shape 1, it is just 60, which is where this line is, and then minus 30, because that's, you're trying to find this value, and we know this whole thing is 30. Oh, I'm sorry. So it's 60 minus 15, because it's half of this. We know this is 15. So 60 minus 15, which is 45. And then to find this distance, we take this, we take the 105 minus 60, which is this value. So we find this height, and then we minus 60, which is 45 as well. So I put those values here. Then we find our moment of inertia. And if you remember, it's this formula, the sum of IXX plus AD squared. And so I just did it for each shape right here, just to have it in the table. And when you calculate that, you get the moment of inertia is 2.7 times 10 to the 7th millimeters to the 4th.